All right, 2.8, function operations and composition. So basically we're going to be adding, subtracting, multiplying, dividing functions, as well as putting functions in functions is what that's telling us. So operations of functions. Given two functions, f and g, then for all values of x, for which both f of x and g of x are defined. So basically just saying like the values in their domain. The functions are defined as follows. F plus g of x is the same as f of x plus g of x. F minus g of x is equal to f of x minus g of x. F times g of x is equal to f of x times g of x. And f divided by g of x equals f of x over g of x, given that g of x is not equal to 0. Obviously, we can't have a 0 in the denominator. Composition of functions. And just to be clear on the stuff that we just listed out, like terms still apply. That doesn't go away. So when we're adding, subtracting, multiplying, and dividing, sometimes it's just combining the two functions together, and there's no like terms. But then if there are, we need to combine those things. Composition of functions. If f and g are functions, then the composite function or composition of f and g is defined by, so there's a couple different ways we can write it. F with a little O looking thing, so it kind of looks like fog. Obviously if it was g of f of x it'd be a little different, but f of g of x is equal to, I prefer this notation I'm about to write, f and then in parentheses g of x. So that's telling us that we take whatever g of x is and we plug that in for x and f of x. I just think that the notation on the right is a little more clear. The book, let's see if I can find it to jump. The book uses the first notation, so just be aware that those mean the same thing and just make sure you understand them. But when I'm actually writing them, I like to write it the way on the right. I just prefer that notation.